Hubble's law expresses a relationship between distance and recession velocity that can be used to estimate distances to very distant galaxies. Scientists have calibrated this relationship by measuring the distances and recession velocities for as many galaxies as possible. Here are some sample data. Each galaxy's distance has been determined using a standard candle technique based on the apparent brightness of a white dwarf supernova that has exploded within it. Each galaxy's recession velocity, which is the speed at which it is moving away from us due to the expansion of the universe, has been determined from the measured redshift of lines in the galaxy's spectrum. The best fit straight line represents Hubble's law. The dashed lines represent the uncertainty range, meaning that the data are consistent with the true law being anywhere between them. Notice that for every 1 million kilometers of distance along the best fit line, the recession velocity increases by about 22 kilometers per second. This slope represents our best estimate of Hubble's constant, h naught, which we state as 22 kilometers per second per million light years. We can use Hubble's law to estimate the distances to the many galaxies for which we do not have standard candle measurements. Suppose a galaxy has a recession velocity of 20,000 kilometers per second. To find its distance, we look across to the line for Hubble's law and down to the distance axis, which gives an answer of about 910 million light years. We can also state Hubble's law with a simple equation: velocity equals Hubble's constant times distance. If we divide both sides by Hubble's constant, h naught, we find that distance equals velocity over Hubble's constant. We can use this equation to calculate a galaxy's distance from its recession velocity, and we'll get the same answer that we get